Hello everyone. We are looking at phase 3, chapter complex number, exercise 1. We have reached the last question number 34 from our package. Let's look at the question. The question is, we have a complex number z and w omega. Prove that z square omega minus omega square z is equal to z minus omega. If and only if z is equal to, okay, it is omega only. Z is equal to omega or z into omega conjugate is equal to 1. Okay, before we start the question, please do not assume that this omega is the cube root of unity unless it is given in the question. So let us just assume that it is just another complex number. You can write it as w or omega, whatever the case may be. That is 1. The second observation is we have to prove z is equal to w or z into conjugate of w is equal to 1. That means if mod is given to us, we have to write it as in terms of its conjugate. Only then we can have conjugate. So conjugate has to be introduced in the given question. So the question relationship is z square w minus w square into z is equal to z minus w. Now, because we had to introduce conjugate here, so z square is equal to z into z conjugate. I don't have to write by now. No. Yes, it's a good question. We have a few things here, a very key concept here. So now this rearrange, okay, z bar into omega minus omega into omega bar z minus z plus omega is equal to 0. Okay. Then how about taking these two? Okay, so z common, we get z bar omega minus 1 and then minus omega, then omega bar z minus 1 is equal to 0. Now, if you look inside carefully in the bracket, I have z conjugate omega and here I have omega conjugate z. Both are not same. So we cannot factor it out. What do we do then? We explore that. We explore what it is actually. And this is what is a very key concept here. So I take back this again, the original equation given to us, and do not open it yet. Just take everything to one side in terms of mod only. Z square omega plus omega is equal to z plus omega square into z. Okay, so same expression, two ways it has been used. First is we unpack the introduced conjugate here. The second is we are using it as it is. The reason is you'll understand now. So taking omega common, we have z square plus 1 is equal to z common 1 plus omega mod omega square. Now this is z by omega or omega by z, whatever the case may be. So you can see z square plus 1 divided by omega square plus 1. Now this is a real number. So z by omega is a complex number. And if the complex number is equal to purely real, it is purely real. So a recall of the property, if a complex number is purely real, if a complex number say C is purely real, that means C is equal to C conjugate. It's purely real. So Z omega should be equal to Z omega conjugate bar. That means Z and that is why we will be able to factor it out. So Z omega bar minus 1, I can take whichever I want because question requires it. And this minus this is equal to 0. Now it is easy. We can see whatever we want to see from here. So either this is equal to 1 or this is equal to, either this is true or this is true. So Z omega bar is equal to 1 or Z is equal to omega. So that is why I star mark this question, because this question, the expression that is given to us was used in two ways. One, we were able to figure it out that the Z by omega or omega by Z is a real number. So we introduced the relation between its conjugate. And the first one, we introduced conjugate in the question because the question asked for it. So through the mod, the conjugates were introduced. So it's a good question. All right. All right. Because I think here explanation made that has not been given very carefully. So that's why I felt it is better that we understand it this way. All right. Thank you.